We've already sort of started exploring what we're going to talk about here today when we were talking about critical numbers and that sort of thing at the end of the last unit, but a lot more about that sort of thing here today. Yeah, what we're talking about is the derivatives and how they shape the graph, or what they can tell us about the shape of a graph, where certain things occur or what's going on with the graph. And what I've got there on the handout is, number one anyway, is I've got a graph, and what I, first of all, want to talk, we talked about increasing and decreasing parts of a graph. That was maybe the very first, yeah, it was the very first day. Well, what we're going to do here today is talk about it a lot more. And remember, the way we approached it, well, it was in that first section, is increasing and decreasing. We just looked at the graph and saw where it was increasing and decreasing. And that's what we're going to start with here on number one, and then notice a few other things. All right, so if we go along the graph, it's increasing if it's going up from left to right, and it's decreasing if it's going down from left to right. And so if you just follow along on the graph here, well, we start by decreasing, and then it turns around here, and then it goes back to increasing in the middle, and then it turns around and goes back to decreasing there, right, on the end. And so as far as where it's increasing and decreasing, well, it's only increasing here in the middle, and it looks like it, as far as the domain interval, would be -2 and +3. Between those two, it's increasing. And then it's decreasing -∞ to -2. And then 3 to infinity. So that's how we approached it from in that first section that we did. First section we covered in the book. Now, however, let's look at it in the perspective, from the perspective of some calculus things. First of all, what are the critical numbers here? What would be the critical numbers for this particular graph? Well, remember, the critical numbers are where the derivative equals 0 or derivative does not exist. Right? That's the two places we have critical numbers, or two types of critical numbers that we have. Now, in this particular case, we don't have any where the derivative does not exist because we don't have any corners or breaks. But we do have a couple of places where the derivative is 0, don't we? Right here at -2 and right here at +3. Now, why do I mention those here at this particular point? Well, do you notice anything about -2 and +3 in our increasing and decreasing intervals? Those are the endpoints of the intervals. So, what we can gather from the graph here, the critical numbers, if I find the critical numbers, that's going to tell us where the endpoints are for our increasing and decreasing intervals. Okay? So those critical numbers are going to tell me those endpoints. Those are going to give me the endpoints. All right? So if I don't have the graph, or I'm not looking at the graph, I don't have to look at the graph because the critical numbers tell me those endpoints. They give me the endpoints. Okay? That's what this confirms here. All right, now, also let me draw a line through those critical values. Okay, so here's what else we can look at on this particular graph. Now, the critical numbers are where we have the breaks, but Also notice the derivative between those critical numbers, or in the different zones, if you will, that are made by those critical numbers. What's the derivative out here? I mean, not specifically, but what sign do the derivatives have out here? Well, if you look at it, you know, the derivative is the slope of the tangent line. Aren't they all negative? Yeah. F prime is negative in this zone. In here, all right, so we've got positive, positive, positive. Those are all positive, aren't they, in this zone between the negative 2 and 3? So F prime is positive in this, one on the left. In the middle is positive. And then what about on the far end over here? Well, again, the derivatives are negative. The slopes are all negative. So the derivatives out here are negative in the one on the right. Well, hopefully then you see the tie-in between decreasing and increasing, and then the derivative being positive and negative. If our derivative is negative, what is the function, increasing or decreasing? It's decreasing, right? So if f prime is negative, the function is decreasing. We have two examples of that, right, showing on this particular graph, right? Because both of the one on the left and the one on the right, the derivative is negative, and we've got decreasing graph. Here, f prime negative, decreasing graph. So you can hopefully see the tie-in there between the two. If f prime is negative, then the function is decreasing. And then vice versa, if f prime is positive, then f is increasing. Okay? So we'll use these two things and think about the critical numbers being the endpoints, and then f prime is negative, it's decreasing, f prime positive, it's increasing. We're going to use that when we don't have the graph or we're not looking at the graph to tell us these things, okay? And then we'll also do some other things with that. Pretty much the same information. All right? So with that in mind then, let's take a look at okay, so let's find, yes, find where f is increasing and decreasing. Using f prime. Okay, and what I'm going to do, what am I going to do? F prime of x equals x cubed all right, so x cubed all right. X cubed minus 3x squared plus 5. Find where that function is increasing and decreasing using f prime. Okay, so here's what I'm going to do. First, that's f. F of x equals that. So I'm going to do f prime and use f prime to establish where it's increasing. All right, so that's 3x squared minus 6x is f prime. So how can I use that to my advantage? Well, the critical numbers are going to tell me the endpoints where f is increasing and where f is decreasing. So I can get the critical numbers here, first of all. And again, I'm looking at f prime of x is 0 or does not exist. So f prime equals 0, we got 3x squared minus 6x equals 0, so that's pretty nice. Factor off of 3x, we get x minus 2 times 3x. So we got x is 0, and so that's x equals 0, and then x equals 2. Those are my critical numbers, okay? So those are going to turn into the endpoints of these where it's increasing and decreasing. Now, here's the way I just show it, and I would like for you to show it as well. All right, so what that's going to establish then are these zones, if you will, of increasing and decreasing. Here. So I've got a critical number at 0, and I've got a critical number at 2. So so that breaks the graph up, if you will, into three pieces. Now, what I know then, if I look at the graph, is f prime is negative. If f prime is negative, then the function is decreasing. So what I'm going to do is, in each one of these zones, pieces, I'm just going to plug in a number into the derivative and see whether it's positive or negative, because that'll tell me whether it's decreasing or increasing. So out here, what I'm going to do is I'm going to plug in, so I've got 0 is one of the endpoints, so if I just choose any value, whatever one you want to pick, in this case I'm going to pick -1, it seems like the obvious choice here, and I'm going to plug that into the f prime and see what value that gives me. So f prime of -1. So I'm plugging it into f prime now. So that's going to go, it's going to be 3 times -1 squared minus 6 times -1. And just evaluate that. These should be fairly quick if you haven't got too complicated of a function. That's 3 times 1, so that's 3. Minus 6 times -1 is plus 6. That's a positive number. So what that tells me is f prime is positive. Now what does that tell me, increasing or decreasing? Well, if f prime is positive, f is increasing. Okay? So that's what I'm doing here. I'm just picking one value out of each one of these pieces and testing it out. So now let me move to here. In this piece, part of the graph, obvious choice would be 1, wouldn't it? So do f prime of 1. So it'd be 3 times 1, that'd be 3. Minus 6 times 1, that'd be 3 minus 6, so that's -3. Yeah, so we've got f prime is negative here, which means then f is decreasing. So in that part, from 0 to 2, we've got decreasing. And then last but not least, 3. Let's do 3 in this piece. F prime of 3, so that would be 3 times 9 be 27. Minus 6 times 3 is 18, so it would be 27 minus 18, positive 9, back to positive 9. So we're back to f prime being positive, and so f is back to increasing. Okay? All right. Well, so it's just kind of reverse of what this one was, isn't it? It's increasing, so it's increasing then, back to the critical number. The critical number is the endpoint, so it's increasing from -infinity to 0. And then it's also increasing, so the endpoint is 2 on this one, 2 to infinity is where it's increasing also. And then it's decreasing between the two, so between 0 and 2 here is where it's decreasing. Okay? So I wrote quite a bit of details there, but more or less is okay. Need to. As we get going, we'll probably shorten that a little bit, but get the general idea here. Okay? So yeah, that's one thing we can get out of these critical numbers, and then also using the derivative to find out where it's positive, increasing. Therefore, the function is so decreasing. All right? So that's one thing we can generate out of this. Now let's look at graph number 2. And we'll see something similar, but with the local maxes and mins. So this is graph number 2 off the handout. Back to it. I can find it. All right, there it is. Okay. Similar to graph number 1, I guess. Call it g of x, though. All right, that's g of x. Yeah, so on number 2 here, let's think about local maxes and mins. And so we did this also previously, talked about local maxes and mins. What local max do we have here? Well, the local max, I've got a local max here at 4, right? G of 4. G of 4, maybe a little more, what does that look like? Probably 4 1/4 or something like that. A little above 4, I think, using my vision here. Maybe a little off, but you agree there? That would be a local max right here. All right. Then we also got a local min at g of 1. And g of 1, it looks like it's maybe 2.1, something like that. Okay. However, hopefully there, and we talked about this, we were going through it, talking about local maxes and mins. What's happening at, what else do we have as far as the derivatives go? What do we have at those local maxes and mins? These local maxes and mins occur at the critical numbers, right? Where the derivative equals 0, or we don't have an example up here, but it also could be where that derivative does not exist. So it's a critical number that those local maxes and mins are occurring at. But even beyond that, to follow up with what we did with increasing and decreasing here, notice on either side of our local maxes and mins here, notice what the derivative is on either side of these. To the left of the local min here, the f prime is, what sign would you say f prime is to the left of the local min here? Well, the slopes are negatives, so the f primes are negative. Yeah. To the right of our local min, our f primes are positive. And so, to the left of a local min, f prime is negative. To the right, it's f prime is positive. Well, notice the reverse is true for the local max. To the left of the local max, you've got f prime positive, but to the right of the local max, you've got f prime is negative. right? And this also gives me a time to mention here. Well, I'll mention it later. Okay. All right. So here's what we want to see. So we've got the local maxes. So again, the critical numbers are going to give us those potential local maxes and mins. That's what the critical numbers can also give us. They give us the endpoints for the increasing and decreasing, but they also tell us about potential local maxes and mins. Now, to further, if we don't have the graph, to further this discussion on the local maxes and mins, if our basically what happens at a local max and min is the derivative changes signs. If it changes signs from negative to positive, you got a local min at your critical number. Okay? So if the sign changes from negative to positive, you got a local min at the critical number. And vice versa. So let me write that down. This is called the first derivative test. For local maxes and mins. Okay. If C is a critical number, of continuous function f, then A, if f prime changes from negative to positive at C, then f of C, so the function value then at C is a local minimum. Just what this graph here kind of indicates here. So we change from f prime negative to f prime positive at our critical number. That's a local min. So that's the first one of the first derivative test. Well, if it does the reverse, if f prime changes from positive to negative at C, then f of C is a local max instead. It's a local maximum. So it changes from positive to negative. You got a maximum there. Now, here's, I was kind of hesitating over here to show you this, but let me show you this. All right, so f prime changes from negative to positive. So if f prime is negative, that generally indicates the motion is downward, right? You've got decreasing, and so you've got the graph is generally headed downward. If it's f prime positive, then the graph is increasing, so it's generally speaking, it may not be as steep or maybe steeper, but it's generally positive there. And the reason I show you that, because this helps, I think this helps you visualize a little better instead of the words. So you got negative turning into positive. Negative turns into positive. So that kind of shows you there that, yeah, you've got a minimum, right? So it's going down and then back up. So that's a minimum. Same thing here. This one's positive, turning over to negative. So it's positive, then turns down to negative. So that, therefore, you have max at C. Okay? All right. Now, there's a third thing that could happen. We didn't have it happen in this graph, but what could happen is it doesn't change from positive to negative or negative to positive. If neither one of those occurs, in other words, if f prime does not change signs, at C. Well, how could that happen? Well, you could have, all right, so here's hypothetical, so here's my C. And I'm just making this up, all right, so let's say f prime on this side is positive, and then f prime is positive on this side. So you've got, it's increasing, and then it's increasing on that side. What do you think that means? Well, if it's increasing, and then it keeps on increasing after, you don't have a max, do you? You don't have a min, because it just keeps going up. There's neither a max nor a min there. Same thing for decreasing on both sides. If you got the f prime not changing signs, it's neither f of c is neither a local max nor a local min. You got neither one of those, okay? And that can happen. I'll show you one in particular here in just a second, okay? So that's the first derivative test. Let me take a look at one of those, all right? So let's find the local mins and maxes using the first derivative test. So f of x equal, let's do negative x cubed plus 6x plus 7. This one. All right, so again, the first derivative test says you got to look at the first derivative. So f prime here is negative 3x squared plus 6. We want the critical number, so we need to set that equal to 0. Obviously, there's not going to be any, does not exist here, so it's just negative 3x squared plus 6 equals 0. Subtract 6, divide by negative 3. So you got x squared equals 2. Which makes critical numbers x equals plus or minus the square root of 2. So we've got 2 critical numbers there. All right. So just like on the increasing and decreasing, I call it the sign chart. Let's make a sign chart over here where our endpoints, if you will, our breaking points are going to be these critical numbers, plus or minus the square root of 2. Because for this first derivative test, I'm interested, negative to positive or positive to negative at these critical numbers. And so, yeah, so I'm going to look at the very same thing I was looking for, increasing and decreasing. You kind of get 2 for 1, if you will. Both things you can read right off of this derivative chart here. Okay, so out here, that's about 1.4, so this is about a negative 1.4. So if I wanted a value out here, let's go with negative 2. So I'm just going to plug in, find out my first derivative at negative 2. What value do I have? Well, plugging it into the first derivative. So that'd be negative 3 times negative 2 squared, so it'll be times 4 plus 6. Negative 12 plus 6, that's a negative 6. So my f prime is negative here. Like I said, if you want to generally indicate a little arrow there, it's negative, so it's downward. So that's in that part. Now go between the two, and since 0 is not one of the critical numbers here, let me just use 0. The one in the middle here. So that's easy. I'm just going to plug in 0 here. So wouldn't that be 0 plus 6? It's positive 6. So f prime is positive here, which generally indicates upward movement there. And then out here we can do, again, that's 1.4 about, so I can do positive 2 or something else bigger than that. But yeah, so let's find out the second derivative at 2. Well, that's again going to be negative 3 times 4 plus 6. That's negative 12 plus 6. That's a negative 6. So f prime is negative. So the general movement on that is downward. Because f prime is negative. Just talk about that. Okay. So what have I got? In this case, I was looking at for local maxes and min. What do I have at square root negative square root of 2? Well, we're going f prime negative to f prime positive. Down, up. What is the function value of negative square root of 2? It's a min, right? So this tells me f prime at negative square root of 2. And, you know, if you wanted to figure out what value that is, plug it in. But I'm just going to say the function value at negative square root of 2. Whatever that is, function value at this negative square root of 2, it's a minimum. Okay? On the other hand, looking at square root of 2, well, at square root of 2, we change from, we're going from positive over down to a negative, and so at square root of 2, f of square root of 2 would be a maximum, wouldn't it? So we can use this little sign chart here to our advantage as well. Okay? Now, when we're going through these problems, though, really we're going to do all this at once. And so, but once you have this, don't we also have the increasing and decreasing stuff built in? Yeah, so if I asked you at this point then, all right, so where's this function increasing? Well, we've already got the critical numbers. We've already got the sign. It's increasing where we have f prime positive. So it's in between these two. So it's negative square root of 2, positive square root of 2. Where is it decreasing? Well, it's where the derivative is negative. So I've got the derivative is negative out here. So that'd be negative infinity to negative square root of 2. Then I'll also have another negative part after the square root of 2. So from square root of 2 out to infinity also, it's decreasing. Okay? So really, those two things go hand in hand. You can use the same information to find increasing and decreasing as you do for the local maxes and mins. Okay? Yeah, I wanted to show you the one example where you can have, it doesn't always alternate. So you can't just assume if this one's negative, this one's positive, it doesn't always alternate. And a good example of that is f of x equals x cubed. F of x equals x cubed. So our derivative there is 3x squared. So our critical numbers would be where that equals 0, which is 0. Solve it however you want to, but the critical number there is 0. Well, look on either side of 0 at the derivative. So the derivative out here at negative 1, to the left of 0 would be 3 times negative 1, that's positive 3. So So f prime is positive here. Well, on our previous examples, if this was positive, then the next one beside it would be negative. But is that true here? What's f prime of positive 1, using positive 1 on this side? F prime of positive 1 is 3 times 1 also, that's 3. Yeah. So you can get f prime positive, positive on either side of a critical number. It doesn't always alternate, is what I'm saying. And here's an example. All right, so how would we indicate that? Or what does this tell us? Well, this tells me, first of all, we've got increasing on this side. And remember the critical numbers, that gives me an endpoint for my critical numbers. And so I have to break it up at 0. But on the other side, it's also positive, so 0 to infinity, it's also increasing. Okay? So that's how you would do that. So it's not always alternating. And then the other thing is, again, as far as local maxes and mins, oh, what about decreasing? Well, there's none. And local maxes and mins? None as well, right? Yeah, you've got to have a change. Change from positive to negative or negative to positive. Here we go from positive to positive. There's no change in the derivative, so no local maxes and mins, which, yeah, obviously, if you look at the graph of x cubed, there's not a local max or min on there. And so that bears that out too. But I wanted to show you, it doesn't always change at a critical number. So you can't assume that it alternates